Okay, so just like the last two solids that we did, we had to talk about cross sections and slicing the three-dimensional solid to see which two-dimensional shape that we get when we pull the two pieces apart after our slice. We have to talk about cross sections with cones as well. All right. So cross sections again could be whichever way you want to slice it. Okay. And if you do slice it, what we call parallel to the base of a cone. So for instance, if I take the cone and I go parallel with my slice to the base, okay, I'm going to go ahead and get a circle. But that circle is actually not going to be the same size circle as the base. You can see that it's actually going to be smaller because you're going up the cone where it narrows to the point. All right. However, that circle, although it doesn't have the same size, so it can't be congruent because congruent means same, it's going to have a similar size. So it will be similar to the base. Okay. So it's the same shape, just not the same size. All right. And so parallel to the base, we get a circle, but it's going to be a similar circle. Okay. It won't be the same size as the base, but it's still a circle. Okay. Now, if I erase my slice here, that was parallel to the base, so I can talk about one that's going to be perpendicular to the base. Okay. So again, my base is still here, but perpendicular to it through what they call the apex or the vertex of my cone here. If I slice it like that, okay, you're actually going to go ahead and get a triangle. Okay. Now, if I slice at a diagonal, okay, not through the base, so for instance, my slice goes this way, same thing happened in a cylinder, you get this oval shape, which is actually called an ellipse. Okay. Now, if my slice goes to the base, okay, you get the same thing that happened in a cylinder where you get this parabola shape. Okay. All right. All right, so number 4 is going to ask us about our cross sections. Okay. Which drawing can't be a cross section of a right circular cone? All right. Well, if you remember, if we slice it perpendicular to the base, that's where we got the triangle. So it's not choice 2. Okay. When you went at a diagonal to the base, we got a parabola. So it's not choice 3. Okay. And this looks like not so much a circle, it looks more of an oval or an ellipse. We got that when we went diagonal to the base as well. We never ended up with a rectangle. Okay? So a rectangle is impossible to get from slicing a cone. Okay? Now, guys, we got to talk about that rotating around. So think about the flag on a pole on a windy day. It goes around and around and around. And the faster it spins, the more it's going to look like a three-dimensional object. When we have our flag in the shape of a right triangle, and that right triangle flag spins around and around and around the pole on a windy day, you can see that it actually is going to make, one second, guys, it's going to make this cone shape. Okay, so it says be careful though. Rotating around a different leg of your right triangle would create a cone with different dimensions and thus a different volume. Okay, so here we go. Let's go ahead and see what this question in number 5 gives us. It says in the diagram below of right triangle ABC has legs whose lengths are 4 and 6. Find the volume of the solid that is formed by continuously rotating the triangle around AB. So AB is where the pole is that this triangular flag is attached to. Okay. And therefore, if that's where the pole is, the flag has to spin this way around the pole and around and around and around. The more times it goes around, guys, the more times it's going to look like a cone. Okay. And so in this case, with this cone, if we stand it up straight, that 6 is actually going to be the height of the cone. And our 4 is going to represent our radius of that circle on the bottom of the cone. Okay. So now part A says find the volume of a cone. So we go to our reference sheet, we copy down the formula for cone, which is 1/3 pi r squared times height. Okay. We're going to keep the volume open since that's what we're trying to figure out. The 1/3 stays, the pi stays, the radius we said is 4 when the flag or the triangle spins that direction, and the height is 6. Okay. Notice there's no rounding directions. Okay. So what we're going to do is we're going to leave this nice pie on our paper and everything else is going to go in our calculator. I highly recommend putting 1/3 in parentheses times 4 squared or 16 times 6. Hit enter and our volume is going to come out to be 32. Because pi stayed on our paper, it'll be 32 pi and there's no units. So we'll just say units cubed because it's a volume. And there is the volume of the cone that's created by the right triangle rotating around or continuously rotating around the side of 6. Okay. All right, so now in part B, let's see what happens. What I'm going to do first is I'm going to redraw my triangle so that we can redraw our picture. Okay. This was 6 and this was 4. This is C, this is A, and this is B. All right, so let's see what we have now. Find the volume of the solid that is formed by continuously rotating the triangle around AC. Therefore, our pole that this right triangle flag is going to be attached to is on AC, and we're going to be rotating our right triangle or our triangular flag, okay, on a windy day, around AC. And so when that happens, this part of the flag is going to go around and around and around, and the more times faster it spins, it's going to look like a cone. Okay, so what we have to realize is that this 4 is now the height of my cone, and that this 6 is the radius of the circle on the bottom there. So now we're going to go back and say, okay, it's a cone. All right. The volume formula for a cone is 1/3 pi r squared times height. We're finding the volume, so we keep that open. The 1/3 goes in, the pi stays. The radius is 6. Don't forget to square it, times the height, which is 4. Okay. Again, no rounding directions, right? So we're going to make sure pi stays on our paper and everything else goes in. So 1/3 is going to go in, make sure it's in parentheses, times 6 squared or 36 times 4. Okay. When we hit enter, we end up with 48. Since pi stayed on our paper, it didn't go in our calculator. It's next to the 48, and we have 48 pi. No units, so we'll just say units cubed. And there's the volume of our cone, okay? So notice that the volumes come out different depending on which way the right triangle rotates around, all right? So be careful that depending on which way it goes, it gives you a different volume. All right, guys, I will see you guys on day 5.